All right, number one, this cube that's outside of these parentheses, it needs to be distributed through first. So make sure you do that. And when you have the 3, this first 3 is not an exponent. So when you bring it to the third power, that means 3 to the third power. Now I'm actually going to erase 3 to the third power and write what it is. 3 to the third power is not 9. It's 3 times 3 times 3, which is 27. So I'm going to put it 27 there. That's what we get. I'm going to distribute that cube to the 3. Then continue from there. Now I have the A. It was to the 4th, and I'm taking it to the 3rd. That's what you multiply. 4 times 3 is 12. For B, 3 times 3 is 9. For C, I'm going to now have C cubed. Over. Okay, I have 6, a to the negative 2, c to the 4th. I have this a to the negative 2, this negative exponent.
I knew I left something in here.
And so because of that negative exponent, I'm going to move it up to the top. When I move that, comes a positive 2. I can cancel that out now. So I have 27, and then the a to the 14th and the a to the 2nd is going to become a to the 14th. Or a to the 12th times a to the 2nd, a to the 14th, and a b to the 9th, c to the 3rd, all over 6, a to the, sorry, not a, but c to the 4th. And then I can now simplify this fraction. 27 and 6 are both divisible by 3. 27 divided by 3 is 9. 6 divided by 3 is 2. And then as for c's, I have 3 c's in the top, 4 c's in the bottom. So I can cancel 3. That means all 3 of the ones in the numerator go away. 3 of the ones from the denominator go away, which leaves us with just c to the 1st, which is c. So now in total, in my numerator I have 9, a to the 14th, b to the 9th. In my denominator I have 2, and then c to the 1st, which is just c. Number 2. 2 times negative 5 is negative 10. X to the 3rd times x to negative 1. You add the exponents here. 3 and negative 1 add to 2. So you have x squared. And then for y, negative 2 and 4 add also to positive 2. And then for z's, 2 and negative 4 add to negative 2. So now I have a negative exponent on the z, so that's got to move to the other side of the fraction. So first of all, I have to write this as a fraction. The negative 10 x squared y squared will stay in the numerator where they were at, and now the z moves down. When it moves down, the exponent becomes positive. So negative 10 x squared y squared over z squared. Number 3, you have a choice, direct substitution or synthetic substitution. Direct substitution is where you plug it in. So everywhere there's an x, you can plug it in. If you choose this option, this isn't the only option, but if you choose this option, make sure you do order of operations. You have to do the exponent before you multiply. So you'd have to take negative 2 to the 3rd. That's negative 8. And you'd have to take negative 2 squared, which is positive 4. And so now you could do your multiplication. So 16 plus 12 minus 10 minus 1. Combine all of that together. So we have 28 minus 10 is 18, minus 1 is 17. So you get an answer of 17. So that's direct substitution. If you did synthetic substitution, because this isn't a factor, it doesn't say x minus 2, it just says g of negative 2, you don't switch the sign. Negative 2 is the number in the box. Your coefficients, negative 2, 3, 5, negative 1. We were not missing any terms, so there's no zeros. Drop down the first number, and then multiply by the number in the box. Negative 2 times negative 2 is 4. Add 3 plus 4 is 7. Times negative 2 is negative 14. Add, you get negative 9. Negative 2 times negative 9 is 18. Add, negative 1 plus 18 is 17. Either way, notice, because when you do synthetic substitution, you only care about the remainder. In both cases, I get 17. Doesn't matter which option you took, you get the same answer. Number 3, we're doing addition. In order to add, you have to have like terms. So look for like terms. make sure that the degrees go in descending order. So it looks like my largest degree is 4. So I have a 3x to the 4th and a negative 2x to the 4th. 3 and negative 2 make 1. 1x to the 4th. You don't have to write the exponent of 1, or the coefficient of 1 rather. You could just write x to the 4th. Then descend from there. Now I'm looking for x to the 3rds. I have one in the first set of parentheses. There is no x cubed in the second set of parentheses, so there's nothing to combine it with. So you leave the negative 3x to the 3rd. Next, I'm looking for x squareds. There is none in the first set of parentheses, but there is in the second. So it's plus 3x squared. Now I'm looking for x. So 5x in the first set, 7x in the second. Combine those together, you get 12x. For a constant, I have a negative 2 plus 3. That's positive 1. So there's our sum. For number 5, it's subtraction. I highly recommend taking that subtraction and distributing it throughout. I'm going to do that in a red pen, change it to addition, and then distribute. The x cubed becomes negative, the 2x squared becomes positive, the x becomes positive, the 9 becomes positive. So I distribute it. Now I can do it addition just like the last problem. So x cubed, 3 is my degree, so a 2 and a negative 1 makes 1, so 1x cubed, or just x cubed. Now I look for x squared. So there's 1 plus 2, that makes 3 x squareds. And I'm looking for x. There's none in the first set, so plus x. Then constants, negative 11 plus 9 is negative 2. Number 6, we have a multiplication problem. Here is where I will distribute. So I'll first distribute the x to every term. Then I'll take the negative 4 and distribute it to every term. So first of all, x times 2x squared is 2x cubed. X times 4x is 4x squared. X times negative 1 is negative 1x, or just negative x. Then distribute the negative 4. Negative 4 times 2x squared is negative 8. X squared. Then negative 4 times 4x is negative 16x. Negative 4 times negative 1 is positive 4. Combine like terms, descending order, so 2x cubed. There's a 4x squared minus 8x squared. That makes a total of negative 4x squared. Negative x and negative 16x makes negative 17x. And constant is positive 4. Divide using synthetic division. So I have a factor of x minus 3. So I have to put positive 3 in the box. My coefficients, I have a 2x to the 4th. Then descend from there. There should be an x to the 3rd. Notice there isn't, which means there's 0x to the 3rd. You better include that 0 or it will mess up your answer. After x cubed should be x squared. I have one of those, so negative 15 is its coefficient. Then x, I have negative 3 of those, and then a constant, that's 1. So drop your first number. 2 multiplied by the number in the box, we get 6. Add, together we get 6. Multiply, 18, add, we get 3. Times 3 is 9, add, we get 6. Times 3 is 18, plus 1 is 19. So how do we get from this to our answer? Remember, these are going to be the coefficients of our answer. We first started with x to the 4th. Because we divided by an x, x to the 4th divided by an x is an x to the 3rd. So we always descend 1 degree, 1 exponent. If I start with the 4, we're going to start with the 3. So this is going to be 2x to the 3rd. The 6 is positive, so plus 6, and that would then be x squared. And then we've got a 3 positive, so plus 3. X, notice we just go down by 1 degree every time. So x cubed, x squared, x. Next comes our constant, which is positive 6. And then the last one is our remainder. For our remainder, we put plus and we write a fraction. The 19 is the remainder. It goes in the numerator. And we divide it by x minus 3. That's the denominator. If we ever have a remainder of 0, we don't have to worry about that fraction. But I did have a remainder this time, so we had to include it. Now we get into factoring. Notice the formulas for sum and difference are both given to us. They will be given to you in the same format on the test. Okay, z cubed plus 27. So 27 is not written as a perfect cube. I would want to start off by doing that first. That way it's the same format as the formulas. 27 is 3 cubed. So I'm going to write it as 3 cubed. Now, it's a cube plus a cube. So we're going to use this first formula. The a of the formula is our z. Not with a cube, just the z. And the b, that's the second base number, that's the 3. So everywhere there's a b, I'm going to put 3. So everywhere there's an a, I substitute in z. Everywhere there's a b, I substitute 3. So, first set of parentheses, it says a plus b, so I say z plus 3. Second set, it says to take your a and square it. So square z, we get z squared. Now it says minus. Then it says a times b. So when I take z times 3, I'm going to reorder that. I call that 3z. And it says plus, and now square the b. So square 3. 3 squared is 9. That right there is what it factors to. I'm finished. Number 9. The 8x cubed, that's kind of complex because it has a number and a variable. So I'm going to use parentheses to show what it's the cube of. 8 is the cube of 2. Next cubed is the cube of x. So in total it's the cube of 2x. Minus, and then 125 is the cube of 5. So my a is the 2x, the entire 2 and x. Keep in mind that it's both of those. And then b will be 5. It is subtraction, so I will use the second formula. It says to take a minus b, so 2x minus 5. Then take the a and square it. Here's where you got to be careful. A had 2 parts, 2 and x. You have to square both parts. When you square 2, you get 4. When you square x, you get x squared. So 4x squared. Then it says plus. Then it says a times b. So we're going to take 2x times 5. 2x times 5 is 10x. Plus b squared. 5 squared is 25. So we finished factoring that. Number 10, factor like a quadratic. It is an x to the 4th, notice that. It is a 1x to the 4th, though. 1 comes from 1 times 1. And look at the last term, the 16, that comes from 1 times 16. 2 times 8, or 4 times 4. Because of the x to the 4th, I'm going to go with an x squared and an x squared. And we know the first coefficients are 1 and 1. So if you want to write in your 1 and your 1, you certainly may. You can write 1x squared, 1x squared. The last terms have to be one of these pairs of numbers. So I might try, let's first try 4 and 4. To see if this works, you have to multiply these inner numbers. 4 times 1x squared is 4x squared. And you multiply these outer numbers. 1x squared times 4 is also 4x squared. Keep in mind, it's a negative 16. So to achieve a negative product, one of the numbers has to be negative, one is positive. If one of those is positive, one's negative, these products that I have up top and bottom, 4 and 4, one of them would be positive and one would be negative. If one of those is positive and one's negative, is it possible to get 6? No. It would make a 0. So that pair doesn't work. So typically, when a pair doesn't work, we switch them around. Switch the 4 and 4. But when I switch 4 and 4, I still get 4 and 4. So we're going to get the same response. So to save time, I'm not going to bother switching them. So I'm going to switch over to 2 and 8. Now, 2 times 1x squared is 2x squared. 1x squared times 8 is 8x squared. So we have a 2 and an 8. We're trying to get 6. Remember, one of them is negative. Well, that's convenient, because if I make 2 negative, I give negative 2 plus 8, which is 6x squared. That's what I want. So I want this one negative. I want the 8x squared to be positive. So now we put our signs in accordingly. The 2x squared needed to be negative, so it came from the middle part, so that 2 needs to be negative. The 8x squared is positive. That came from the outer part, so the 8 needs to be positive. So I'm going to rewrite it since it's a little messy, but one of my sets of parentheses, one of my factors is x squared minus 2. One of them is x squared plus 8. Number 11. First of all, I made a mistake. It shouldn't say 2x squared, it should say 2x to the 4th. So you can make that change. Otherwise we couldn't have done the problem. But now we can. So 2, think about the numbers 1 and 2. For 12, it could be 1 and 12, 2 and 6, or 3 and 4. When we set up the sets of parentheses, because of the x to the 4th, I know it's an x squared and an x squared, but unlike last time, it's not a 1 and a 1, we have to have a 1 and a 2. So one of them will be a 1x squared, one of them will be a 2x squared. Now let's try one of our pairs of numbers. I might try 3 and 4. They do multiply to a negative, which tells us one of them is positive, one of them is negative. Okay, this middle pair, 3 times 2x squared will be 6x squared. The outer pair, 1 times 4 will be 4x squared. Remember we said one was positive, one's negative. 4 and 6, if one's positive, one's negative, they will not make 5, so that's not the right pair. So, instead of giving up on 3 and 4, switch the order around. Try 4 and then 3. That will give us a different combination. It may work, it may not, but we'll try it. We won't know unless we try. So, now the inner pair, 4 times 2x squared is 8x squared. 1x squared times 3 is 3x squared. One of them will be positive, one will be negative. We're trying to get 5. Success. I can make the 3 negative. 8 minus 3 is 5x squared. So I wanted the middle one to be positive, so the 4 needed to be positive. I wanted the outer one to be negative, so the 3 needed to be negative. So if I rewrite that again, I have x squared plus 4, and I have 2x squared minus 3. So x squared plus 4 and 2x squared minus 3. Now we'll go to the back page. Graphing, we have a few steps. Hopefully you remember the format, just like the worksheet. After the semicolon, this x minus 1, that's the factor. That's what we're going to use when we get down to synthetic division. So we're first focusing on what's before the semicolon. X cubed plus 4x squared plus x minus 6. Of that, state the degree. The degree is the largest exponent. The largest exponent I see is 3, which is an odd number. That's what we would observe there. The leading coefficient. Go to the degree that, the term that had the degree of 3, and look at its coefficient, the number in front. In this case, there was no number there, so I know it's a 1, which is positive. So for my end behavior, the right side, whether it points up or down, depends on whether your leading coefficient is positive or negative. It was a positive 1, so the right side has to go up. Then for the left side, remember the degree was odd. 3 was odd. If the degree is odd, one side points up, one side points down. When it's even, they both point the same direction. But this was odd, so one's up, one down. We already established that the right was up. That means the left has to be down. And then we'll come back to that when we do our graphing. But let's move now to synthetic division. They gave us a factor of x minus 1. It's a factor, so I switch my sign to positive 1. Okay, my first coefficient was a 1, so that was x cubed. X squared is a 4, x is a 1, and the constant is a negative 6. There are no zeros. My remainder should be a 0 since it tells me that's a factor. Drop your first term down. 1 times 1 is 1. Add together, you get 5. 5 times 1 is 5. Add together, you get 6. 1 times 6 is 6. Add together. We do, in fact, have a remainder of 0. Off to the side here, I might write what I have at this point. I just factored out x minus 1, so I need to include it. And now 1, well, this was x to the 3rd, so this must be an x squared. So 1x squared plus 5x plus 6. The remainder is 0, so I don't include that. So now in the next step, where it says factors, they want me to factor this further. So I have x minus 1 already. But that trinomial should factor down further. Remember, we have a 1 and a 1. either 1 and 6 or 2 and 3. So a 1x and a 1x. We can try 2 and 3. Since they multiply to a positive, they both have to have the same sign. They're either both positive or both negative. When I multiply these inner two, 2 times x is 2x. The outer two, x times 3, that's 3x. 2x and 3x make 5x, that's what I wanted. I wanted a positive 5, so I wanted them both to be positive. We knew they had to have the same sign, so I now determined that they're both positive. So there's my factors, an x minus 1, an x plus 2, and an x plus 3. I might go back and erase these signs here so they don't get distracting. They don't distract me with the answer. But that's how I got it. Okay, so now for zeros. Zeros are what you get when you set each factor equal to 0. You have a factor of x minus 1. Set it equal to 0 and solve. We have a factor of x plus 2. Set it equal to 0, solve. We have a factor of x plus 3. Set it equal to 0 and solve. When I solve the first one, add 1, I get x equals 1. If x plus 2, set that equal to 0, I get negative 2. X plus 3, if that equals 0, I get negative 3. So my zeros are 1, negative 2, negative 3. I can put those on my graph right now. Positive 1, these are x, zeros are x-intercepts. So positive 1, there's an x-intercept. Negative 2, there's an x-intercept. And at negative 3, there's an x-intercept. Those are the only places you'll touch the x-axis. Your y-intercept is just the constant. Prior to the semicolon, though. Prior to the semicolon, the constant is negative 6. That's my y-intercept. So on my y-axis, I can go to negative 6. 1, 2, 3, 4, 5, 6. Put a point. We know it touches there. So then for our graph, we now sketch it. Using the end behavior, the 0 is the y-intercept. The end behavior, we said the right side's going up. So as I look at my points, my rightmost point is the 1. So when I go to the right of that, I know it has to point up. My left one is down, so go to your leftmost point, that's the negative 3. When you move to the left of that, you know it's pointing down. I know I have to hit this y-intercept, so I know it does that. None of these were double roots, so it should hit the point and pass right on through. So we just kind of connect the points, and there's a sketch of our graph. Number 13. Largest exponent is 3, so degree is 3, which is odd. Leading coefficient is 4, positive 4. It is positive. That tells us the right side then is going up because it was positive. Since it's odd, there's an up and a down. We already had the up, so left is down. Synthetic division. We have a factor of x minus 2, so positive 2 goes in the box. We had a 4x cubed, a negative 4x squared, a negative 7x, and a negative 2. So let's do synthetic division here. Should get a remainder of 0. 4 times 2 is 8. 4 times 2 is 8. Get a 1. 1 times 2 is 2. Add those together, we get a remainder of 0. It was in fact 0. So I just factored out x minus 2. And now I'm left with 4, that'd be an x squared, plus 4x plus 1. We'll have to list the factors, but pay attention to the 4. It's either 1 and 4, or it's 2 and 2. Pay attention to the 1. It has to be 1 and 1. So factors. We have the x minus 2. I already pulled that out. So next two sets of parentheses. We'll try a 2 and a 2, so 2x and 2x. We know the last numbers have to be a 1 and a 1. They multiply to a positive, so they're the same sign. Let's check the inner here. 1 times 2x is 2x. Check this outer. 2x times 1 is 2x also. 2x and 2x do combine to make the 4x that I want. I want them both positive. I wanted the same sign, so that works out. So I get a 2x plus 1 and a 2x plus 1. To give myself room and not get distracted, I'm going to erase those markings in the middle. It tested and it worked out. So those are my factors. X minus 2, 2x plus 1, 2x plus 1. Now for zeros, set each factor equal to 0. Set x minus 2 equal to 0, solve, we get 2. Set 2x plus 1 equal to 0. When you solve that, you have to subtract the 1, so 2x equals negative 1. Then, because of the 2, you have to divide that. You have to divide by your 2. So we get x equals negative 1/2. And then the next factor, 2x plus 1 again. It's the same factor, so of course I'm going to get the same 0. So when we have the same 0 twice, we call it a double root. I'm putting dr to indicate double root. So at 2 we have a positive root, at negative 1/2 we have a double root. The y-intercept, the constant prior to the semicolon, that's negative 2. I'm going to put all these marks on here. A 0 of positive 2, at negative 1/2, and it's a double root, so it's going to bounce there. The y-intercept, we hit negative 2. So I've got those points on there. The right end behavior, the right's going up. The left is going down. So we hit 2, we have to come down and hit that y-intercept, and then we've got to come back up, and remember it bounces, it's a double root, so it bounces and goes right back down, so your graph's going to look similar to that. That's just a sketch, it's not exact, but it's going to look pretty close to that. Alright, thanks for watching.